Hello and welcome to this repair tutorial, and today we're going to look at a Cambridge Azur 540A, and this is the version 1 amplifier. If we look at the general specifications, so its power output is 50 watts into 8 ohms or 75 watts into 4 ohms, and frequency response is 5 Hz to 50 kilohertz, and total harmonic distortion is 0.09%, so that's a good specification. And good range of input signals, so you can connect directly auxiliary inputs, CD, tuner, DVD, AV and tape. It also has a preamp output mode as well. And then where you see input say aux, and this sort of links to one of the issues that this amplifier came in with, it normally says Phono stroke aux, but it can lead to some confusion, and the reason for that is that you think that it's a switchable input from the front of the amplifier, but it isn't. You need internally to fit the Cambridge moving magnet circuit board, which was used on the A5, A500, etc. And yeah, not switchable. So in terms of dimensions, so standard, so 440 millimeters wide by 310 depth, and then height is 100 millimeters, and overall weight comes in at 7 kilograms. Now the amplifier is supplied from the dealer or from the factory with a full range remote control. So the remote control of course will be used to adjust the volume, but then you can select any of the input channels, and on the version 1 you don't have a rear power switch as you do on the version 2. So just be aware of that when you come to sort of carry out any repair work. Internally what happens if you do it via the remote or the front push button, the circuit itself just provides 5 volts, which is to the microcontroller, which is housed just behind the front switch panel. It's actually on the same board the microcontroller is, and then it just sends the command signal out to a small switching circuit, which in turn powers a relay on the input power board, and as soon as it energizes, the contacts close, and then it provides that mains voltage to the toroidal, and then in turn the toroidal then provides multiple voltage outputs. You can over time just get some key bounce, and that's dead normal. You know, you can imagine how old some of these amplifiers are, but they're just surface or low profile push buttons, and you can get these, you know, from any electronic repair or supply company. Now the amplifier had seen extensive use, but the other thing which I want to highlight, and you can see this in the video, yes, there was a lot of dust internally, but it had come from an environment where it was a smoker. Now I'm not going to use the channel to say what's good or wrong about smoking. What I do want to highlight is if you undertake repairs, you will from time to time encounter electronic equipment that has been in a smoke environment for a number of years, and that adds additional work and time that you need to allow. So for me, it probably took the best part of about 1.5 hours literally to go through each one of the circuit boards and clean them. But what you'll find, the nicotine coats the inside of the casing as well, and again it took about 3 different cleaning cycles to get rid of it, or to effectively eliminate it. So I had the initial clean, then a second clean, and then the last one then contains a deodorizer, and that normally gets rid of all of the nicotine smell. Now although the nicotine coats the circuit boards, it also goes inside the potentiometers, so you will need to clean them quite extensively with De-Oxit to try and get them to come back with no noise or anything like that. I have had other cases where the nicotine contamination has been so severe that you cannot get the potentiometers to come back, and then I've had to replace them then. Now this amplifier came in and it must have had a moving magnet, the Cambridge one, installed. Now that can be retrofitted, or could have been retrofitted by the owner, or you could order it directly then with the amplifier as it's supplied from the dealership. Now when you look at the rear of the amplifier, and logically it's by the RCA input connectors, what you'll find is that there are two links which are marked on the board, and those two links, and you'll show them, is LK1 and LK2. And what you have to do is you have to cut these links. Use a pair of side cutters, and once you cut the links and you install the circuit board, it goes onto a multi-pin connector, and then you have a bolt which comes through the board, and then the kit would be supplied then with a anti-slip nut, and then normally a 4BA nut on top of that. So you insert the board, screw it into place or lock it into place with the nut. Once you cut the links, the circuit or the signal then will come in directly from a turntable, and then routes then into the equalizer stroke pre-amplifier board. And then after that, once it exits left and right channel, it then goes on, of course, then into the signal processing circuit as well. Now, you'll also see in the video the input selection IC, which is used, and it's very, very common that these ICs fail. And the reason for that, it's not so much that the IC fails under normal operation. It tends to fail because of user error. If you connect different input signals, and maybe you disconnect maybe the left channel and the right channel is still connected maybe to the aux, and then you go and plug that other channel then into the next input signal, you'll get an imbalance, and that can also destroy the input selection switch. The other thing to bear in mind is that it does kind of run warm under normal operation. So when you check the circuit board, and again I'll show this in the video, you will get heat related dry joints around that area. So just reflow the resistors, and these are the feed resistors that provide the DC power to the input switching IC. So straightforward repair from this point of view. To fix no signal from the aux stroke phono input, you just replace the two links, LK1, LK2. Now, often on a lot of the backdrop videos, in the title page you'll see Curse of the Brown Glue, and what I'm referring to, and it's just to sort of add a little bit of comedy behind it, but it is serious. This time period, pretty much all audio manufacturers use this type of glue. No problem when it's first manufactured, but what happens is over time the glue dries very, very hard and becomes almost like a plastic, hard plastic material. It's no longer any elasticity in there. And then the other part is that it goes corrosive, and then the next part then is it also goes slightly conductive. So if it's covering any components, so resistors, etc., or even wire links on the board, for this type of amplifier you've got to remove it. So just use a plastic scraping tool, some eye protection. Don't do it without, because I'll guarantee it will flick up and cause eye damage, and just get that out there. Sometimes you'll have amplifiers like the Cambridge 540 series come in, and then you get this intermittent operation with a Cat 5 circuit, and you think, well, what's going on there? If you check the circuit board, you'll find this brown glue is just coating all these different links, and of course you can get in signal or voltages being transferred, and that's what's triggering the protection circuit. So what I have to do, and what I did for this amp, there are feed resistors, and you'll come back to that in the circuit diagram. The glue coats them and they go open circuit, and that's when you get this DC protection fault where the protection LED then is flashing. So just to provide longevity, I've gone in there, I've removed the glue, and then I've replaced one of the feed resistors, which is R42, R43, but we can see that in the schematic. So once that's done, I know and I'm confident that the user can continue using the amp for many, many years, and it's not going to prematurely fail because of this brown glue. Now, the other thing that was replaced are the speaker protection relays, but there is only one in this amplifier. In the version 2 there are two of them, and you see that on the speaker board. They're Masseuse type relays, and the model number is ME-11 012-2 Z4, and they have a switching contact rating of 8 amps at 250 volts. So that means it's a 12 volt coil double pole changeover relay. There are two, one for the speakers and then the other one is for the power input board. As I said, there's a circuit then which feeds via the microprocessor, energizes, and you can get this contact, because it's quite a large toroidal, the contact's entirely just wear. So instead of you getting clean switch it can sometimes be not so clean and it may not switch over correctly, or it might generate some noise, and then you can find the amplifier sometimes going into protection mode. Just to eliminate all of that, I just replace both of the relays. And then in terms of functional check and then testing the amplifier, what I show here in the video is a snapshot then of the left channel circuit. So this is the complete output stage, input processing stage, but remember that this is not showing any tone circuits or the input board where the RCA connectors come in, right? Because you have multiple op amps on those boards. What this is where it comes off that board and it goes via a multi-pin connector, and there's two audio signal leads that come off, and they just go for the left and right channel. So you can see here where it shows the input circuit, and then the first thing that it does, it goes into these long tail pair. Maybe if you had an issue with high DC offset, this is the area that you tend to focus on. So Q7 for example, or Q8 may well have an issue, or you could see maybe an issue with Q9 or Q10. And then after that, then it then feeds directly then into the driver stage, and the output circuit is very familiar. If you repaired A500 amplifiers or A5 Cambridge amplifiers, this isn't sort of unique what you've seen here. It uses Sanken output transistors. These are Darlington type, and they're SAP15N, so that's the NPN, and 15P, the PNP. Now, if you're testing these transistors with a multimeter, just be aware that they are Darlington type. So that means it's two transistors in the same package, and here they also show some internal resistors which are also in there. So if you use a multimeter, it can be slightly misleading trying to check them, but if you maybe use a transistor tester, normally the modern day transistor testers will tell you these are Darlington devices then. I don't really have any issues in terms of amplifiers that come in, like the 540 series or 640 series, where these output transistors have failed. Normally the circuit is very reliable, whereas on the A5, you know, it's kind of underrated, and they wanted it to deliver 60 watts and the circuit track was pretty poor. I wouldn't say it was the best circuit board that they used on that amplifier, and then they overheated because the heatsink was insufficient, and then you did get some failures then of the output transistors. With these amplifiers, not really seen it, and I've repaired hundreds of them. So I'm also showing the resistor, which is the one I referred to earlier. So that's R43, that's 150 ohms, and I just replace it. Make sure that there's no glue contamination anywhere on that board, and of course I removed it. And then what you then do is you then connect your multimeter across the emitter resistor, which is coming from the SAP-N transistor. And then I'll leave the amplifier running for about 15-20 minutes just to stabilise, and then what I'll then do is just adjust the preset that's being marked there until you read 13 millivolts. The nice thing with this amp is they used a 10-turn preset. Very, very easy then to precisely set the millivolts. On the other amps like A5, A500, A300, it's just a single turn 100 ohm preset and quite coarse. Here, not the same issue. Now, because of the nicotine, you know, and I said of course that it would also coat, you know, the potentiometers and everything else. Well, my advice is, you know, just give it a go. You may clean them, and I did in this case, but you may not be able to. So, you know, it just depends on how bad that contamination is. Alright, so that kind of brings us to the end of this tutorial. So not too sort of, you know, difficult, you know, no major sort of fault finding or anything like that. But good insight that you can use for any amps that you've got yourselves and you want to look at. And if you have any questions, by all means email audioamplifiersourcing@aol.com, and I'll always be happy to respond back to you and provide any insight, maybe schematics, any advice that you need. And as I say, if you look at the landing page of this channel, and this is probably the #1 kind of questions that I get, if you've got a PC, it's probably easier to see rather than a mobile device. If you go into the landing channel, you can just do the search function on the channel. So if you type in maybe Cambridge or Pioneer, whatever is the amplifier you want to look for, the window will open up then, and then you'll see the initial fault description. And then that's why the knowledge base part comes in. It's dead easy just to pick up your amp and then say, okay, hey, that looks to be exactly the same symptom that I'm seeing. And then if you just click onto it, you'll be able to open it up, look at the fault description, and then in most cases it will tell you even what component you need to replace to bring it back to normal operation. These latter videos, you get the audio tutorial and then also the write-up as well. Alright, okay, so thanks very much. Until the next time, I wish you well. Cheers, bye bye.